Welcome to The Explainer. Today, we're going to decode a piece of everyday magic. You know, those pictures that seem to come alive and change right before your very eyes?
You've definitely seen these your whole life. They're such a common part of our world that we usually just dismiss them as simple novelties. You might know them as flickers, winkies, or maybe wiggle pictures.
I mean, think about it. Those old postcards where the eyes would wink at you, or album and movie covers that would morph as you walked past. Maybe you remember those little animated prizes you'd get in a Cracker Jack box. They were even used in political campaigns. That famous I Like Ike button from 1952 is a perfect example.
It honestly seems like magic, right? But it's actually a brilliant and, believe it or not, a surprisingly old piece of technology. So let's dive in and see exactly how the trick is done. Okay, so the official name for this is lenticular printing. It's probably a name you don't know, but the effect is something you have definitely seen. It's the technology that gives a normal printed image the illusion of depth or the ability to change and move.
The entire illusion, the whole thing, is made possible by this bumpy, ridged plastic surface. And what's really cool is how simple the core idea is. See, each one of these tiny ridges is actually a lens, called a lenticule, and that is the key to the whole trick.
So what it really boils down to is a clever method for showing you different images depending on the angle you're looking from. This lets it pull off two main effects. It can show your left and right eye two different things to create a cool 3D illusion, or it can make the image change completely as you tilt it back and forth.
So how does it all come together? Well, it's basically a two-part trick. It involves the image itself and that special sheet of lenses that gets placed right on top of it. It all starts with the image. Or actually, images. You take multiple pictures, slice them up into super thin strips, and then weave them together into one single picture. Then you put that special lens on top to reveal only one set of strips at a time.
This first step has a name. It's called interlacing. The different images are all digitally sliced up and then combined, creating what just looks like a single, kind of jumbled picture.
Okay, so imagine this. You take a blue image and a green image. You slice them both up into thin vertical strips. Then you arrange them one after another. A blue strip, then a green strip. A blue strip, a green strip. That final image is your single interlaced picture.
And now for part two, where the magic happens. That sheet of lenticular lenses is placed right on top of our interlaced image. Each tiny little lens is perfectly aligned with the strips below it, and it acts like a tiny focused magnifying glass. So from one angle, it directs the light from only the blue strips to your eye. But you tilt it just a little and boom, it shows you only the green.
Okay, so now that we've got the basic principle down, let's look at how this one technique can create all those different effects that we're so familiar with. There are pretty much three main types of illusion here, and it all depends on how wide the lenses are and how many images you weave together. First, you've got your transforming prints. These use a wide viewing angle for a really clean flip between two totally different images. Then there are animated prints, which use a whole sequence of images to create a short morph or motion effect. And finally, you have stereoscopic prints. These use really narrow angles, so each of your eyes sees a slightly different image. And what does that do? It tricks your brain into seeing a 3D effect. No glasses needed.
Now, you'd think this is a pretty modern invention, right? Like some digital effect. But the core idea behind this tech has actually been around for centuries.
No, seriously, the basic concept of images that change based on your angle, that dates all the way back to the 1500s with these things called turning pictures. But the modern version we know really took off when plastics manufacturing got big in the mid-20th century. It blew up as a novelty with that I Like Ike button, and it was even immortalized on the cover of the Rolling Stones album Their Satanic Majesty's Request.
By the 60s and 70s, this technology was absolutely everywhere. I mean, it became a staple of pop culture. It was used for everything from prizes and Cheerios boxes to Hallmark's Magic Motion greeting cards. So this might all seem like a pretty simple novelty, but, and this is the crazy part, creating a clean, seamless effect requires an unbelievable level of engineering precision. The magic disappears real fast if things aren't absolutely perfect.
Get this. To make this work, the printing press has to align that interlaced image to the lenses with an accuracy of just 10 micrometers. To put that in perspective, a single human hair is about 70 micrometers thick. So we're talking about 1/7 the thickness of a hair. Any mistake, any tiny deviation, and the magic is completely gone. And right here, you can see exactly why that precision is so important. These are microscopic images showing these tiny, irregular cuts on the edge of the lens material.
Even a defect of just a few micrometers is enough to throw off the entire alignment between the lens and the printed image sitting underneath it.
And when that happens, you get this. This effect is called ghosting. It's what happens when the alignment isn't perfect, and you start seeing parts of one image bleed through when you should only be seeing the other. It's the most common flaw you'll see, and man, it completely ruins the illusion. So what starts out as just a simple trick of light and plastic actually turns out to be a true marvel of precision manufacturing. It's just an amazing testament to how much engineering can go into creating even the simplest seeming piece of everyday magic.
It really makes you wonder, doesn't it? What other everyday marvels, what other bits of so-called magic are hiding some really clever science right there in plain sight, just waiting for us to take a closer look?